All right, here is our applications of polynomial functions notes. This video is going to be on the application problems for quadratics. In class, we'll talk about application problems for cubics. So here we're going to focus on projectile motion problems, and then for cubics, we'll focus on volume problems. So here the problem says a water balloon is catapulted into the air so that its height in meters after t seconds is modeled by the equation h of t equals negative 4.9 t squared plus 27t plus 2.4. They want us to sketch the path of the water balloon on a set of axes before we begin answering the questions. So I'm only going to draw the first quadrant, positive x values, positive y values, or in this case, instead of x, we're using t, which stands for time in seconds. And then for the y-axis, we have h of t, or height, which is in meters. And so for this, they didn't tell you specifically in the problem if it was launched off the ground or if it was launched from a height above the ground, but if you plug 0 in to see what the y-intercept is, you can see that plugging 0 in would get rid of those two terms and that the height would be 2.4. So the water balloon would go up into the air and then come down. Something like this. Okay. So this is going to be the launch. This is going to be the maximum height of the water balloon. And then this is going to be where the water balloon hits the ground. So we can see that the launch is the y-intercept, the maximum height is the vertex, and then where the water balloon hits the ground is going to be the x-intercept. There's another x-intercept over here, but that x-intercept is kind of extraneous. In this case, we're not going to use it. So off to the side, we're going to go ahead, let's write t comma h of t. And just know that for all the values that we find on our calculator, because we're going to do use our calculator for all these problems, that the x-coordinate in our calculator is going to be time, and that the y-coordinate in our calculator is going to be the height. Because even though this problem for us is in terms of t and h of t, our graphing calculators are always in terms of x and y. All right, so let's go ahead and plug the equation in. So I'm pulling up the y equals screen on my calculator, negative 4.9x squared plus 27x plus 2.4. And whenever I have a word problem, if I want to figure out how big my calculator screen should be, I always look at my table just to figure it out. So I already know that I'm going to use positive x values, positive times, because negative time doesn't make sense. But I want to see how big my heights should be. So I'm not going to use any of these. Negative heights don't really make sense. My water balloon is not going to go into the ground. But if you can see, my water balloon goes up into the air. It goes, the highest that I can see on my table with whole numbers for the time values is 39.3. So when I go to my window, I didn't want to graph it yet. I want to have my x max values go at least to 5, which it already is going to because it always goes to 10 when I first start. But I want my y max values to go above 39.3. So when I hit my window, my x min and x max are fine. Having the negative values there are fine. I don't have to change that. But I do want my y max value to go above 39.3. So I'm going to say above 40. I'm just going to put 50 so I can see plenty of information on my screen. So there's my graph. I can see everything that I need to see. Okay, so now I'm going going to start looking at the questions, and I want to figure out what each question is asking for. I want to see if it's asking for a y-intercept, if it's asking for a vertex, if it's asking for an x-intercept, and I want to see if my answer should be an x-coordinate or if it should be a y-coordinate. So if it's an x-coordinate, it's going to be asking questions about the time. It might be asking questions about for how long. That's an x value question. It might be asking questions about when will. That's an x value question, or in this case, I guess we could say t. It's a t value question. Or when is. It's an x value question, aka a t value question. So those are all the questions where the x coordinate is going to be the answer. Anytime they want the height to be the answer, they're going to say, like, what is the height? What is, and then height. So this is where they want the y value, or h of t. How high? They want the y value, or h of t. What is the maximum height? What is the maximum height? The y value, or the h of t. That's going to be the answer. So typically, based on what they're asking you to find, they've given you either something to plug in or it's one of those specific points. So maybe here they didn't give you something to plug in, but it's the x-intercept, so you know how to find it. Okay? So let's go ahead and look at the first question. It says, what is the initial height of the balloon? So here they didn't give us something to plug in, but it's one of those specific points. The initial height of the balloon is the y-intercept. Well, and actually they kind of give you something to plug in because the y-intercept tells you to plug in x equals 0. So number one, this is the y-intercept. You're going to plug in x equals 0. So on our calculators, we're going to do second trace, option number 1, plug in x equals 0. And we get 2.4. So if you want, I'm going to go ahead and write my instructions for how I'm doing each of these off to the side. That would be a good thing for you to do as well, so that you have really good notes to yourself, because these are notes. So second trace, number 1, x equals 0. And we have the point 0, 2.4. And the y value is the answer. I'm going to go ahead and just write all my answers down, and then I'll put my sentences in a little bit. So the next question, how high is the balloon after 1 second? So this is giving me a value to plug in. So that means that I'm going to plug in t equals 1, or x equals 1. So I'm going to take this to plug in any x value I want, second trace, plug in 1. 24.5. So second trace, number 1, x equals 1. So I get 1, 24.5. Okay. For how long is the balloon more than 30 meters high? So here they gave you an h of t value or a y value. They told you that the y value is 30. So what we do is we have y1 is the equation itself. What we're going to do is we're going to put a y2 in there, and we're going to put that in as 30. So I'm going to go ahead and graph this. I'm going to draw a picture on my paper. So I've got something like this. So I'm going to have two places. There's two places where the balloon is exactly 30 meters high. Now the balloon is more than 30 meters high for this entire piece right here. So it starts being 30 meters high right here, and then it's more than 30 meters, more than 30 meters high, more than 30 meters high until here. So we need to find these 2 times. So I'm going to do second trace, number 5, to find those 2 intersections. Okay, so second trace number 5, and I'm going to go ahead and find the first one. Enter, enter, enter. There's the first one. 1.35584 And I'm writing all the decimals down because I don't want to round until the end of the problem. So I'm just writing all my decimals now. And then second trace, number 5. Go to the other one. Press enter, enter, enter. 4.154361. Okay, so there's my 2 times. It starts being 30 meters high at 1.35584 seconds, and then it being 30 meters high at 4.154361 seconds. So I'm going to go ahead and subtract those. 4.154361 minus 1.35584. And now I can go ahead and round to 3 decimal places. 2.799 seconds. Okay. I haven't written my sentences yet. I'm going to come back to that later. What is the maximum height of the balloon? This is the vertex, aka the max. Okay, so I'm going to do second trace number 4. All right, so my maximum is 2.755, 39.594, and the y value is the answer. That was second trace number 4. When will the balloon burst? As it hits the ground. We know that the balloon hitting the ground, we already saw this in our drawing up here, this was our x-intercept. So x-intercept, so we need to do second trace number 2. Now there are 2 x-intercepts on this graph. There's one over here and one over here. The only one that I want for this problem is the one over here. So I'm going to do second trace number 2. $5.598. And then last question, when is the balloon 27 meters high? Very similar to number 3, except instead of saying for how long is it something, it just says give me the exact moments where it's 27 meters high. So we don't have to say for how long, we just have to say those 2 exact moments. So we want to know when h of t is 27. So the process is very similar. We're going to take this, change it to 27, and then do that same process again. So let it graph, same thing. My drawing was terrible. I'm going to fix that. Okay, there we go. That's a little bit better. So second trace. So we got 1.152. 4.358. Okay, so now, and if we were to write these out as points, it would be 1.152, comma 27, 4.358, comma 27. Okay. So what we're going to do now is, because these are story problems, they deserve story answers. So when it says, what is the initial height of the balloon? I would say the initial height of the balloon is 2.4 meters. How high is the balloon after 1 second? The balloon is 24.5 meters high after 1 second. For how long is the balloon more than 30 meters high? The balloon is more than 30 meters high for 2.799 seconds. What is the maximum height of the balloon? The maximum height of the balloon is 39.594 meters. When will the balloon burst as it hits the ground? The balloon hits the ground after 5.598 seconds. When is the balloon 27 meters high? The balloon is 27 meters high at 1.152 seconds and 4.358 seconds. So I wrote the first 2 sentences. You need to go ahead and write the other 4 sentences before you take a picture and submit your notes. Then do not do the rest of the notes. We will do the rest of the notes in class tomorrow.